Good morning. We have an exciting one for you today. We started this 12-day event 12 days ago with the launch of O1, our first reasoning model. It's been amazing to see what people are doing with that and very gratifying to hear how much people like it. We view this as sort of the beginning of the next phase of AI, where you can use these models to do increasingly complex tasks that require a lot of reasoning. And so for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2, but out of respect to our friends at Telefonica, and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3. Actually, we're not going to we're going to announce two models today, O3 and o3-mini. O3 is a very, very smart model. o3-mini is an incredibly smart model, but really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. The good news is we're going to make them available for public safety testing starting today. You can apply, and we'll talk about that later. We've taken safety testing seriously as our models get more and more capable. And at this new level of capability, we want to try adding a new part of our safety testing procedure, which is to allow public access for researchers that want to help us test. We'll talk more at the end about when these models, when we expect to make these models generally available. But we're so excited to show you what they can do, to talk about their performance. Got a little surprise. We'll show you some demos. And without further ado, I'll hand it over to Mark to talk about it.
Cool. Thank you so much, Sam. So my name is Mark. I lead research at OpenAI. And I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SweetBench Verified, which is a benchmark consisting of real-world software tasks. We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really climbing the frontier of utility as well. On competition code, we see that O1 achieves an ELO on this contest coding site called Codeforce is about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2,500.
That's tough.
Well, I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there. Great.
I mean, this model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores. So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AMI.
What's your best AMI score?
I did get a perfect score once on this, so I'm safe. But yeah,
congratulations.
Really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science questions. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at 78%. Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie. And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is Epic AI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is considered today the toughest mathematical benchmark out there. This is a data set that consists of novel, unpublished, and also very hard to test.
These are extremely hard.
Yeah, very, very hard problems. Even Turnstile says, it would take professional mathematicians hours or even days to solve one of these problems. And today, all offerings out there have less than 2% accuracy on this benchmark. And we're seeing with O3, in aggressive test time settings, we're able to get over 25%. Yeah.
That's awesome.
In addition to Epic AI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point, but I would love to invite one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this benchmark.
Wonderful. Sam and Mark, thank you very much for having us today.
Of course.
Hello, everybody. My name is Greg Camrad, and I'm the president of the ARC Prize Foundation. Now, ARC Prize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ARC AGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ARC AGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that, though, I want to talk about what ARC AGI is. So I would love to show you an example here. ARC AGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now, the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that width.
That is exactly it, and that's much quicker than most people, so congratulations on that. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ARC AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ARC AGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that o3 has scored a new state-of-the-art score that we have verified. On low compute for o3, it has scored 75.7 on ARC AGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ARC AGI Pub. So congratulations to that.
Thank you so much. Yeah.
Now, as a capabilities demonstration, when we ask o3 to think longer and we actually ramp up to high compute, o3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand. So this is new territory in the ARC AGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this o3 world. But the work also is not over yet, and these are still the early days of AI. So we need more enduring benchmarks like ARC AGI to help measure and guide progress. And I am excited to accelerate that progress, and I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Amazing. You know, it's also a benchmark that we've been targeting and been on our mind for a very long time. So we're excited to work with you in the future.
Worth mentioning that we targeted and we think it's an awesome benchmark.
Yeah.
We didn't go do specific work with
specific
this. This is just
yes,
you know the general o3. But yeah, really appreciate the partnership. And this was a fun one to do.
Absolutely. And even though this has done so well, ARC Prize will continue in 2025, and anybody can find out more at arcprize.org.
Great. Thank you so much for coming on.
Absolutely.
Yeah. Okay, so next up we're going to talk about o3-mini. o3-mini is a thing that we're really, really excited about, and Hongyu, who trained the model, will come out and join us.
Hey.
Hey,
How are you?
Hey.
Hi, everyone. I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released o3-mini, which is an efficient reasoning model in the o1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with o3, I'm very happy to tell you more about o3-mini, which is a brand new model in the o3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Yeah, though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for o3-mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases. So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of o3-mini. So on the left-hand side, we show the coding evals. So it's like code forces elo, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, o3-mini is able to have increasing elo, outperforming o1-mini. And with median thinking time, it's able to measure even better than o1.
Yeah, so it's for an order of magnitude more speed and cost, we can deliver the same code performance on this eval,
or even better experience, right? So although it's the o3-mini high is still a couple 100 points away from Mark, it's not far. It's better than me, probably.
But just an incredible sort of cost to performance gain over what we've been able to offer with o1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code forces elo trade-off. So it's pretty clear that o3-mini defines a new cost-efficient reasoning frontier on coding. So it's achieved better performance, compared with better performance than o1 with a fraction of cost.
Amazing.
With that being said, I would like to do a live demo.
That sounds great.
On o3-mini. And hopefully you can test out all the 3 different low, medium, high thinking time of the model. So let me paste the prompt. So I'm testing out o3-mini high first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this Python script, it will launch a server locally with a UI that contains a text box. And then we can make coding requests in a text box. It will send the request to call o3-mini API, and o3-mini API will solve the task and return a piece of code, and it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
very complicated,
pretty complicated task, right? And it outputs a big chunk of code. So if we copy the code and paste it to our server, and then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah,
I hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great. We have a UI where we can enter some coding prompts. Let's try out a simple one, like train OpenAI and a random number. Submit. So it's sending the request to o3-mini medium, so it should be pretty fast, right? So on this
41.
terminal, yeah, 41. That's the magic number, right? So it saves the generated code to this local script on the desktop and then print out OpenAI 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask, just as what I expected. We practiced a lot yesterday.
Yeah.
Okay, so now let me copy the code. And send it in the code UI. So in this task, we asked the model to evaluate o3-mini with the low reasoning effort on this hard GPQA data set. And the model needs to first download the raw file from this URL, and then it needs to basically figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the o3-mini with low reasoning effort. Yeah, let's see how it goes.
I guess 2 tasks are really hard here.
Yeah, the long tail is often the problem.
Go.
Yeah, GPQA is a hard data set.
Yes.
Yeah, it contains like maybe 196 easy problems and 2 really hard problems.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results. It's 61.62%, right?
Amazing.
62%, right?
Cool.
With a low reasoning effort model, it's actually pretty fast. Then full evaluation in a minute.
Somehow very cool to like just ask a model to evaluate itself like
Yeah,
this.
exactly, right? And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this like hard GPQA data set. From a UI, right, from this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on, and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
Besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with like on this AMI 2024 dataset, o3-mini low achieves comparable performance with o1-mini, and o3-mini medium achieves like comparable better performance than o1 if we check the solid bar, which are past ones. And we can further push the performance with o3-mini high, right? And on the right-hand side plot, when we measure the latency on this like anonymized o1 preview traffic, we show that o3-mini low drastically reduced the latency of o1-mini, right? Almost like achieving comparable latency with GPT-4o. Where it's under a second, so probably it's like instant response. And o3-mini medium is like half the latency of o1.
Got it.
And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support like function calling, structured outputs, developer messages on o-mini series models. And here, o3-mini will support all these features, same as o1. And notably, it achieves like comparable better performance than 4o on most of the evals, providing a more cost-effective solution to our developers.
Cool.
And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it's actually o3-mini low is actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right? Next time, we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah, so with that, that's it for o3-mini, and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah, thank you
really
so much.
great work on you.
Thank you.
Cool. So I know you're excited to get this in your own hands, and we're working very hard to post-train this model to do some safety interventions on top of the model, and we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with o3-mini, and also eventually with o3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover. Cool. Great. So one other thing that I'm excited to talk about is a new report that we published, I think yesterday or today, that advances our safety program. And this is a new technique called deliberative alignment. Typically, when we do safety training on top of our models, we're trying to learn this decision boundary of what's safe and what's unsafe, right? And usually it's just through showing examples, pure examples of this is a safe prompt, this is an unsafe prompt. But we can now leverage the reasoning capabilities that we have from our models to find a more accurate safety boundary here. And this technique, called deliberative alignment, allows us to take a safety spec, allows the model to reason over a prompt, and also just tell, is this a safe prompt or not? Oftentimes within the reasoning, it will just uncover that, hey, this user is trying to trick me, or they're expressing this kind of intent that's hidden. So even if you kind of try to cipher your prompts, oftentimes the reasoning will break that. And the primary result you see is in this figure that's shown over here. We have our performance on a rejection benchmark on the x-axis and on over-refusals on the y-axis. And here to the right is better. So this is our ability to accurately tell when we should reject something, also our ability to tell when we should refuse something. And typically, you think of these two metrics as having some sort of trade-off.
It's really hard to do well on both at the same time.
It is really hard to do, yeah. But it seems with deliberative alignment that we can get these two green points on the top right, whereas the previous models, the red and blue points, signify the performance of our previous models. So we're really starting to leverage safety to leverage reasoning to get better safety.
Yeah, I think this is a really great result of safety.
Yeah. Fantastic.
Okay, so to sum this up, o3-mini and o3, apply please if you'd like for safety testing to help us test these models as an additional step. We plan to launch o3-mini around the end of January and full o3 shortly after that. But that will, the more people can help us safety test, the more we can make sure we hit that. So please check it out. And thanks for following along with us with this. It's been a lot of fun for us. We hope you've enjoyed it too. Merry Christmas.
Merry Christmas.
Merry Christmas.